I'm Alexandre Zagoskin. I'm a reader in quantum physics. I teach two modules: Methods, Philosophy and Frontiers of Physical Science and Quantum Computing. Why these two modules? First of all, quantum computing is a very interesting subject, fascinating. But it is only a important part of what's going on right now. The second quantum revolution, if the first quantum revolution that happened starting about 100 plus years ago brought us much of modern technology. The fact that you can see and hear me is the result of developments in quantum physics of solid-state systems. Lasers, nuclear power, and superconductors is also part of this first quantum revolution. But it only dealt with the kind of most basic quantum phenomena in small systems. What's going on right now, starting roughly in the beginning of this century, is the second quantum revolution, which deals with the quantum properties of much bigger systems and much subtler ones. So quantum computing, quantum communications, all of this is part of this current development. And this has a very interesting and very tough set of problems to solve, which belong roughly, generally to the field of quantum engineering. How to actually properly describe and predict the behavior of so big quantum systems that it is fundamentally impossible to do it using usual computers. And how can you design a quantum computer if you cannot actually use another quantum computer to do it? This is part of quantum engineering. This is the main field of my interests. I might say contributed somewhat to this, including a book and being part of the development which led to the production of first commercially available quantum computing devices. Now about philosophy and methods of physical science. This is also very important. Physics is arguably the most successful field of knowledge, with extremely accurate predictions for the behavior of systems from very small, like subatomic particles, to very big, like galaxy clusters and black holes, and who knows what else. So physics is extremely successful, and in order to understand why, and understand what is most important, why did it happen, and how can we continue using physics to such a big effect, we need to know how it works. So we need to know its methods, we need to know their limitations, we need to know the philosophy which was developed in the process of centuries of scientific research and hundreds of discoveries. And this is very interesting as well. In your first year, when you need to properly go through all sorts of difficult and dry subjects like mechanics and calculus and so on, which is necessary, absolutely necessary for you to properly learn physics, it would be good to have a wider perspective of what physics is and what it is not, and what science is and what science is not. So, welcome to our Department of Physics.